All right, in today's lesson, we are learning about trigonometric ratios, or trig ratios for short. So we just finished a unit on similar triangles. And remember, with similar triangles, we have congruent angles, and then our corresponding sides were proportional, meaning their ratios were equivalent. So we are going to look at some specific ratios of right triangles. Those ratios are called sine, cosine, and tangent. So the sine of angle A, which angle A is this angle right here, is equal to the length of the leg opposite of A, which is this side over here, over the length of the hypotenuse, which is the side across from our right angle. The cosine of our angle A is the length of the leg adjacent to A. Adjacent means it's the leg right next to it, or the leg touching our angle, over the length of our hypotenuse, which is this side. The tangent of angle A is the ratio of the length of the leg opposite of A. So again, that's that side over here. It's the side across from A, over the length of the leg adjacent to A, which again is this side. You will see these three ratios abbreviated a lot. The abbreviation for sine is SIN, but it is still pronounced sine. The abbreviation for cosine is COS, and the abbreviation for tangent is just TAN. But we still say sine, cosine, tangent. It's not sin, cos, tan. Sine, cosine, tangent. So the sine of angle A, which would look like this, is equal to the length of the leg opposite of our angle over the length of the hypotenuse. So I'm going to shorten this up and put sine A is equal to O for opposite over H for hypotenuse. Cosine of A is the length of the leg adjacent over the length of the hypotenuse. So I'm going to shorten this by putting A for adjacent over H for hypotenuse. And for the tangent of A, I'm going to write this as O for opposite over A for adjacent, since the ratio of tangent is the length of the leg opposite over the length of the leg adjacent to A. Now we have a phrase we use to remember these ratios. It is called SOHCAHTOA. SOHCAHTOA. So for the first part, the S in the SO stands for sine is opposite over hypotenuse. The C stands for cosine. So cosine is adjacent over hypotenuse. And the T in the TOA part stands for tangent. So tangent is opposite over adjacent. All the letters match up. SOHCAHTOA. So we are going to find some of these ratios and see what they look like. We're going to find sine, cosine, and tangent of our angles x and y in this right triangle we have up here. So if I want to find sine x, first of all, I'm going to write my SOHCAHTOA up here. It's a good reminder. I want sine of x. First of all, our angle x is up here, to the left. Sine is opposite over hypotenuse. So I know I'm using opposite over hypotenuse. The side opposite of our angle x is 16. And the hypotenuse of our triangle is 17. If we put this in a decimal form, 16 divided by 17, this is approximately 0.941, and I'm rounding to 3 decimal places. Now let's find the cosine of angle x. So we're still talking about this angle up here. Cosine, if I look at my SOHCAHTOA, cosine is adjacent over hypotenuse. The side adjacent or next to x is 15. And our hypotenuse is 17. 15 divided by 17 gives us approximately 0.882. Now let's find sine and cosine of y. So now we are switching angles. We're talking about this angle at the bottom right, angle y. Sine, again, is opposite over hypotenuse. So I'm going to write over h. The side opposite of angle y is 15, or it's the side that doesn't touch angle y. It's across from it. Then our hypotenuse is again 17. 15 divided by 17 is again approximately 0.882. Notice how the cosine of x is the same as the sine of y. So now we want to find the cosine of y. Cosine is adjacent over hypotenuse. The side adjacent to y, or the leg that's next to y, is 16. Our hypotenuse is still 17. 16 divided by 17 gives us approximately 0.941. So sine of x and cosine of y are also the same. Now let's find tangent of x and tangent of y. If we look up at our phrase, SOHCAHTOA, the T in TOA stands for tangent, so I know tangent is opposite over adjacent. So opposite over adjacent. The side opposite of our angle x is 16. And the side adjacent to our angle x is 15. It's the leg that touches the angle. 16 divided by 15 is approximately 1.067. And now we want to find the tangent of y. So we're switching angles again. We're talking about angle y over here. We're still using opposite over adjacent. The side opposite of our angle y is 15. And the side adjacent to our angle y is 16. 15 divided by 16 gives us approximately 0.938. Now I just want to check and make sure you guys have your calculator set up right for what we are about to do. Please make sure your calculator is set to degrees. Usually it'll say somewhere on your calculator screen. If you don't have a good calculator that will use sine, cosine, tangent, go to Desmos, I'm going to write it up here, desmos.com/scientific. And make sure that button in the middle says DEG and not RAD. You need to change it to degrees. So if you type in sine of 40 degrees into your calculator, you should get approximately 0.643. If you type in cosine of 60 degrees, you should get 0.5. And if you type in tangent of 85 degrees, you should get approximately 11.430. Type those into your calculator. Make sure you get what I got. If you didn't, your calculator is probably not in degrees. We're going to put this all together. We're going to take the trig ratios that we learned and apply it to triangles to find a missing side length. So on this first example, we are given the angle of 41 degrees over there in the left. We are also given the length of 11, which happens to be our hypotenuse of our triangle. And we want to find x. And x is adjacent to our angle of 41 degrees, meaning it's the leg next to it. So I'm dealing with an adjacent leg and a hypotenuse leg. If I have SOHCAHTOA, this is a good thing to remember. I have adjacent and hypotenuse, so I want the ratio with the A and the H, which is cosine. So I know I'm using adjacent over hypotenuse. So cosine of our angle, which we know is 41 degrees, should be equal to the adjacent leg over the hypotenuse. So x over 11, since x is our adjacent leg and 11 is our hypotenuse. So that's the setup, and now we just need to solve for x. Since we have an x divided by 11 on the right, to get rid of that 11 in the denominator, I'm going to multiply by 11. So we have 11 on the top and an 11 on the bottom, so they cancel. And now I also have to multiply an 11 on the other side. If you multiply something to one side of an equation, you have to multiply it to the other side as well. So this gives me x is equal to 11 times the cosine of 41 degrees. If you type this into your calculator, you type 11 times, you'd hit the cosine button, then 41 degrees. This should give you approximately 8.302. So make sure you got that answer and make sure you typed it in correctly. Some calculators are different. Next example, we are given the angle of 64 degrees. And we are also given this side length over here, which is 7. And that side length is adjacent to our angle. And we want to find x. X is opposite from our angle of 64 degrees. So now I want the trig ratio that has opposite and adjacent, and that is tangent. Tangent is opposite over adjacent. So I'm using tangent. The tangent of my angle, which is 64 degrees, should be equal to opposite over adjacent. So x is our opposite side over 7, which is our adjacent side. And I'm solving for x, so I need to get rid of the 7 in the denominator. So I multiply this side by 7, so they cancel. Then I multiply the other side by a 7. So x equals 7 times the tangent of 64 degrees. So you'll type that into your calculator. 7 times the tangent of 64 degrees should give you approximately 14.352. And again, if you didn't get that, you might be typing it in wrong, or you might not have your calculator set in degrees. Next example. We're given the angle of 36 degrees. This 10 over here is opposite of our given angle, and our x is our hypotenuse. So I want the trig ratio that deals with opposite and hypotenuse, which is sine. So sine is opposite over hypotenuse. Sine of 36 degrees equals opposite, which is 10, over hypotenuse, which is x. Now I have an x in the denominator. To solve for x, I need to take it out of the denominator. I'm going to do this by multiplying an x on this side and an x on this side. So the x is on the right, since we have an x on the top and an x on the bottom. They cancel. So I'm left with a 10 on the right side. On the left, I am left with x times the sine of 36 degrees. I'm still trying to solve for x. So I need to divide both sides by the sine of 36 degrees. So the sine of 36 degrees on the top and the bottom cancel. So I'm left with x is equal to 10 divided by the sine of 36 degrees. If you type this whole thing into your calculator, you should get approximately 17.013. Make sure you type that in and get that answer. Last one. We have the angle of 25 degrees. It's given to us. We have the side with the 10, which is opposite of our given angle. And the x is adjacent to the given angle. It is the leg that's next to it, and it's not the hypotenuse. Our hypotenuse would be over here, across from our right angle. We don't need that. So I want the trig ratio that deals with the opposite side and the adjacent side, which is tangent. Tangent is opposite over adjacent. So the tangent of 25 degrees has to equal 10 over x. That's my opposite over adjacent. Again, to get rid of the x out of my denominator, I need to multiply by an x on both sides. X over x becomes a 1. So we have a 10 over here, and an x times tangent of 25 degrees over on the left side. To get x by itself, we need to divide both sides by the tangent of 25 degrees. Tangent of 25. So x is equal to 10 divided by the tangent of 25 degrees. When you type that into your calculator, just as it appears, you should get approximately 21.445. And that's all I have for you today.